G'day Year 7s. Today we're moving on to Chapter 6E, which is angles and parallel lines. Okay, so we're looking at something similar to what we've done already in terms of our parallel lines and angles, but we're actually combining them for this lesson. We'll jump straight into the key ideas. I'll highlight some stuff that I want you to copy. We'll go from there. Okay, a straight line that crosses a pair of parallel lines is called a transversal. All right. So that's this line here going through two parallel lines. That is what we call a transversal. When a transversal crosses a pair of parallel lines, it creates a number of angles, many of which are equal. I'll draw an example of this afterwards, but I just want you to understand that once we draw a transversal across two parallel lines, there are many angles that are made, some of which are equal. There's three types of angles that are made when we use a transversal across a pair of parallel lines. We have alternate angles, corresponding angles, and co-interior. I'm going to go into more detail with each of these. What I want you to do is once we've done this slide, you're going to copy these down. All right. Alternate angles are on the opposite or the alternate sides of the transversal, and they are between the parallel lines and are equal in size. Okay, so if I zoom in to this top one, they're on either side of the transversal. That's our transversal. Our alternate angles are on either side. So one on this side, one on this side, and they are both between the parallel lines. Okay, so there can only be one, when you're looking for the alternate angle, there's only one that's going to be. Okay, and you'll understand that a little bit more when we look at the questions. But basically, it is alternate angles are on the opposite sides of the transversal, so one's on the left, one's on the right, and they are between the parallel lines, which we've got here, and they are equal in size. Corresponding angles are on the same side of the transversal and in the same position on parallel lines, either both above or below the line. They are equal in size. That's these ones here. Okay, so the middle one. There's our transversal. Our corresponding angles are both on the same side. So you can see that they're both on this right side. And they're also both on the same point of the parallel lines. So these angles are both below these parallel lines, and they are the same. Okay, so again, they are on the same side of our transversal. They're both on the right side, and they're both in the same position on the parallel lines. The last one we have is co-interior or allied angles. They're on the same side of the transversal and between the parallel lines. They're supplementary, meaning they add up to 180 degrees. These ones are probably the easiest to find because it is just, they're both on the same side of the transversal. So again, they're on the right here, and they're in between the two parallel lines. So it's just these two angles here. All right. These two are the ones we are looking at. They add up to 180 degrees. All right. That is your co-interior. So just going through it again. Alternate angles are on the opposite sides of the transversal. Corresponding are on the same side of the transversal and in the same point on both parallel lines. And the co-interior are the two angles on the same side of the transversal in between the two parallel lines. What I want you guys to do is you need to have these examples in your book. Okay, you need to make them quite clear and easy to understand. You don't have to copy all this in word for word, but I'm just highlighting it because this is the key information you're going to need to have. So whether you summarize that yourself, or if you think you need to copy it word for word, or if you think your drawings are good enough to understand, that's fine by me. What I'm going to do on this next page is quickly draw an example that should help us understand a little bit easier what I mean by many angles are made when we draw a transversal, and that they create angles that are the same. So I've got my parallel lines, and I'm going to draw my transversal. So that's just gone through there. Perfect. What I'm going to do is I'm going to get two colors, and I want you guys to do this in your books as well. I'm going to have green angles and red angles. Okay. green, 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 red, 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 red. Now, I want to do it up here. Red equals same size. Green, same size. So, as you can see, that there are only two possible sizes of angles we're going to have. Okay, and that depends on what numbers we're given in our actual example. But basically, any of these points at all, they're only going to be one of two answers. Okay, and you'll understand that a little bit more when we get to the questions. But basically, this is just a way of seeing how many angles you're going to have and what the different values are. And I'll give you another thing just quickly once I change the color. If we have a red and a yellow angle, if you combine them, they're going to add to 180. Okay, so any combination of red and yellow, so those two there, or these two here, or these two here, or these two, or these two, any combination of red and green, if you've got one red and one green in those positions, they're going to add to 180 degrees. Okay, and if we have a full circle, so I'll quickly rub these out. If we had this full circle, it's one revolution, and add to 360 degrees. Okay, so that information there should help us when we get to the questions and we're actually solving the size of the angles. What I want you guys to do is underneath your notes, I want you to copy this in. Okay, just draw your parallel lines, draw your transversal, put your colors in, your red and your green, and then this up here as well. Okay, so that should help us with understanding what angle is equal to what, because all our questions are going to look similar to that in terms of you've got a parallel line and a transversal. Moving on, here is an example. Okay, these are the type of questions you might be getting. Over here, name the angle that is alternate to C. Okay, if we're looking at C, C is there. We need to look at our the characteristics of what makes an alternate angle, which are here. Alternate angles are on the opposite side of the transversal. Okay, so we're going to be on the opposite side. So if we've got C here, our angle is going to be on this side. It's going to be on the right side. It's going to be somewhere over here. Okay, we know that alternate angles are equal, don't we? They equal the same because it says it up here. So they're between the parallel lines and are equal in size. So if we know that we've got C here, our other one is going to be on this right side of the transversal, and it's going to be between the parallel line, it can only be F because they are the same. They have the same value. All right. Our corresponding for our second one, what is the corresponding to E? We're going to quickly do this. E is here. What was our characteristics of corresponding? Corresponding angles are on the same side of the transversal. So that means it's going to be on the left side. It's going to either be C or A. Now, what's the other characteristic of a corresponding? If we go back to here, they're on the same side of the transversal and in the same position on the parallel lines. We go to there. E is on the left side, so our other angle is going to be on the left side. It is above the parallel line, so we need to find the other angle that is above the parallel line, which is A. So the corresponding angle to E is A. Now, this is where that drawing that I made comes in handy quite a bit, okay? So if we're finding the size of each unknown angle, what I want you to do, this can help you out, draw your colors in, because it'll easily show you what the answer is. If our red dot here is 64 degrees, this red dot here is going to be 64 degrees because they're the same angle. Okay, so there you go, X is 64 degrees. Looking at B, again, if you need to draw them in, let's draw them in. and that is a red there. Now, we're trying to find the value of y. Here, we have a red and a yellow. Remember, if we had a red and yellow, it adds to 180 degrees. All you're going to have to do, like they've done down here, 180 degrees, take away 37, gets you to 143. So y equals 143. That's where our green and red dots can come in handy, because it just helps us visually see what angles are going to be the same and what angles are going to be different. And if they're different, they're going to add to 180 degrees. Moving on, this is another example, and this will just be the same thing, but it's just not actually transversal. So all we need to do to work this out is to actually draw our transversal. So you just continue on with these lines. So let's put that one there, they're parallel like that. Okay, so now we've got a normal transversal with parallel lines. Again, that's going to be a green dot, green dot, green dot, green dot, and then our reds. If this is green dot and that's a green dot, if the green dot's 35 degrees, what's A going to be? The value of A will also be 35 degrees. Okay, you guys are going to get questions given to you by your teacher, focusing mainly so far on the first couple of examples we did. So this example here, questions 5, 9, and 10. They're the main ones you'll be doing so far. Please email your teacher or let your teacher know if you aren't sure about anything that's been covered in this video, because we want you guys to do the best you possibly can. Okay, so you guys need to let us know if you are struggling. Other than that, watch this video. Hopefully it helps with your work, and we'll go from there. Thanks, guys.